In this lesson, we're going to explore a few more examples of some exponential functions. So let's start out with the following function. Let's say you had f of x is equal to 1/2 to the power of x plus 3. So this is different than the examples that we encountered in the last few videos because we have never dealt with a fraction before as our b value. You can recall from the previous video that the general form of an exponential function was f of x is equal to a times b to the power of x plus q. And thus far, we've dealt with examples where b was a whole number. So let's take a look at what happens when we have a fraction. Well, the first thing that we can do is make a note of our y-intercept because that can be quite easily determined. Our y-intercept is going to be when we set x equal to 0. And you can recall that anything to the power of 0 is going to be 1. That is one of our exponent laws. Anything raised to the power of 0 becomes 1. So this term is going to become 1, and 1 plus 3 is 4. So our y-intercept is 4. That means our coordinate of our y-intercept is going to be when x is equal to 0 and y is equal to 4. Then another thing that we can figure out just by looking at this function is that our horizontal asymptote is going to be y is equal to 3. You'll remember from our last video that we could determine the horizontal asymptote as y is equal to q, and in this case our q is 3. So y is equal to 3 is our horizontal asymptote. So now let's take a second to just draw out a Cartesian plane over here where we're going to graph our function. So here we have our Cartesian plane, and I'm going to put in our horizontal asymptote as a dashed line in red. So here in red we have our horizontal asymptote at y is equal to 3. And I always recommend first and foremost putting in your asymptotes as dashed lines because it'll just make things a lot easier when you are graphing this function. Now before we make an xy table where we put in different input values for x and see what we would get for y, let's take a second to try and conceptualize what this curve might look like. So because we have a fraction here, there are a few things that we can make note of. When we have negative x values, having that negative exponent that we would have for negative values for x is going to imply that this fraction can flip, and whatever is in the denominator can actually become a numerator. So when we are in our negative values for x, this is actually going to become a whole number. This would become 2 raised to some power because if we have our negative exponent, we would flip our numerator and denominator. So for negative values for x, we are going to have large y values. We're going to have a large value over here that's going to be added to 3. So when we have our negative values for x on this side of the Cartesian plane, we're going to have very large y values. So it's going to look like the exponential part of our curve is going to be on this side. As we get into the greater negative values for x, we're going to have exponentially larger increases in y. So we're going to have this side of the graph looking something like this. On the other hand, when we go into our positive values for x on this side of the curve, in our positive values for x, we are going to have this term with our x in it, this variable term, is going to approach 0 because we're going to have a fraction raised to a positive exponent, which is going to make this entire term get closer and closer and closer to 0. But because we're adding 3 here, we're going to be adding an increasingly smaller number that's approaching 0 to 3. And that means that on this side of the axis where we have our positive x values, we're going to have something that is going to be above 3, but very closely approaching 3. So already, just by looking at this information that we have here, we're going to have a pretty close idea of what this graph is going to look like. We know that our y-intercept is going to be when x is 0 and y is 4. That's going to be right here. This is where we're going to cross our y-axis. And we know that on this side, we're going to have exponentially increasing values for y as we go into our more negative x values. And as we go here, we're going to have values that are going to be increasingly closer to 3. We're going to end up with a curve that looks something like this. So let's take a second and actually draw out an xy table and find our actual points and prove that this is the shape of our curve. So I'm going to remove our curve quickly and let's take a second to draw out an xy table. So when x is equal to -3, our y value is going to be 11. And you can validate this by plugging this into your calculator. If you plug in -3 for x here, you are going to get a value of 11. If x is -2, y is going to be 7. If x is -1, we're going to have a y value of 5. When x is 0, we're going to have a y value of 4. That is our y-intercept. When x is 1, we're going to have a y value of 3.5. When x is 2, we're going to have a y value of 3.25. And when x is 3, we're going to have a y value of 3.125. So already we can see that the trend that we predicted just by conceptually looking at this is true. As we go into further x values, we're exponentially increasing our y values. And as we go into our positive x values, we are getting closer and closer to 3. So we're coming from above 3 and we are decreasing closer and closer to 3. And if we plot all of these points, we're going to get... So we can see that we do indeed get a curve that looks very similar to the curve that we sketched out before doing this. So you don't even need to have these XY tables where you do a bunch of calculations. If all you need is a general idea of what your graph is going to look like, getting this information and just conceptualizing what is actually happening as we go from our positive to negative x values, you can pretty easily sketch a quite accurate depiction of what your curve is going to look like. Now I'm going to quickly get rid of this information here. And the next thing I want to do is look at a function that is very similar to this, g of x now instead of f of x, since we're differentiating our two functions. And our new function is going to be -1/2 to the power of x plus 3. So our only difference is that instead of a positive a, we are going to now have a negative a. And let's see what the effect of having a negative a is going to be on the appearance of this graph. So again, let's try and figure out our y-intercept. Our y-intercept is going to be setting our x value equal to 0. We know that anything raised to the power of 0 is 1, but because we have a negative here, this is going to become -1. And -1 plus 3 is equal to 2. So our y-intercept coordinate is when x is equal to 0 and y is equal to 2. Our horizontal asymptote is still going to be y is equal to 3. So y is equal to 3 is still our horizontal asymptote, and I'm just going to abbreviate that here. So we have the same horizontal asymptote here, although our y-intercept is now different. We have a y-intercept of 2. So let's take a second to put that y-intercept onto this plane. So our y-intercept of 2 is going to be right here. This is where y is equal to 2 and x is equal to 0. And let's take a second to actually conceptualize what would be happening here. So here, when we have a negative x value, if we have negative values for x, we're going to again have a negative x exponent. And that means that we're going to flip our numerator and denominator. So we are going to have this 1/2 to the power of x becoming a pretty large number. But because it's negative, it's going to be a large negative number. We're going to have a large negative number here in our negative values for x that is going to be subtracting from 3. So as we go into our negative x values, we're going to have an exponentially negative y values, and it's going to be approaching the asymptote in this direction. When we have positive values for x, we are going to have this term approaching 0, but it's going to be approaching 0 from the negative side. So we're going to be subtracting an increasingly small negative number from 3 as we increase into our positive values for x. So that means that our curve is going to be in this shape. Our curve is going to look something like this. And we know that just from conceptualizing this, as we get into our negative x values, we're getting exponentially negative y values. And as we cross into our positive x values, we are going to be subtracting an increasingly smaller number from 3. So we're always going to be less than 3 since we're subtracting a very small number from 3. And that shows us we're approaching 3 from the negative side. And again, we can take a second to actually draw out an XY table and confirm that this is the shape of the graph that we do get. So if we make a little XY table here, when x is equal to -3, y is going to be equal to -5. When x is -2, we're going to have a y value of -1. When x is -1, we're going to have a y value of 1. When x is 0, we're going to have a y value of 2. That is our y-intercept. When x is 1, we're going to have a y value of 2.5. When x is 2, we're going to have a y value of 2.75. And when x is 3, we're going to have a y value of 2.875. And if we plot those points, we do indeed get a curve that looks like the same one that we sketched out before we did this. So I'm just going to get rid of this so we can give ourselves a little bit more room. So here we have f of x, and this was the curve of g of x. And let me just quickly write down that g of x was equal to -1/2 to the power of x plus 3. So these were our two curves. And what's one thing that we can notice about these two graphs? Well, when we have a b value that is between 0 and 1, that means that we have a b value that's a fraction. If b is a fraction and we're raising a fraction to the power of x, the way that our graph is going to curve, whether it curves upwards or downwards, is going to depend on our sign of a. So let's quickly make a note of that. When we have a b value in between 0 and 1, that means our b value is a fraction. If our a is positive, we're going to have an a value of either 1 in the case of f of x or -1 in the case of g of x. So if we have a positive a value and b is a fraction, then we are going to have our graph curve downwards. We're going to have a downwards curving graph, and that is what we can see here with f of x. If our b is between 0 and 1, that means again we have a fraction as b and our a is negative. We have a negative a. Then we are going to curve upwards, and that's what we see with g of x here. We're curving upwards. And another thing that we can notice is that depending on the sign of a, depending on whether our a is positive or negative, we are simply going to have a reflection around our horizontal asymptote. So we can see that g of x is the same as f of x, just reflected about the horizontal asymptote of y is equal to 3. And in the next video, we'll explore 2 more examples. But this time, our b is going to be a whole number, so we're not going to have a fraction. And we're going to see what our curves are going to look like depending on whether our a is positive or negative.